Welcome back. So we have our bot pawn, and it has a bot mesh, it has a spring arm and a camera component, but we still can't move it. And to move it, we need input. We need to be able to press buttons, move the mouse, and have that result in moving our pawn. And in order to make that happen, we have to make use of Unreal Engine's Enhanced Input system. Enhanced Input involves a number of parts that come together to allow us to handle input for the pawns that we possess. So we need to make a couple of new classes, and we're going to keep those new classes in their own input folder in Blueprints. So I'm going to right-click, choose New Folder, and call this folder Input. We'll go into Input, and we'll make a new type of asset here related to input. Let's right-click and find the Input category, and here in Input, we're going to choose Input Action. Now, before I click on it, take a look at the pop-up and read it. The first line says, an input action is a logical representation of something the user can do, such as jump or crouch. These are what your gameplay code binds to in order to listen for input state changes. We're going to see what that means very soon. Let's go ahead and click on Input Action, and we prefix our input actions typically with IA, which stands for Input Action. Now, I'm going to call this IA Fire, as in firing a weapon. This is going to be a very simple type of input action. I'd like this to represent the action of firing a rifle. I'm going to double click on it and open up the input action asset. Here's what it looks like. It's quite simple. And really the most important thing to look at here is the value type, which has a dropdown. It says digital bool, and we know that bool or Boolean data types have only two possible states, true or false. An input action that has a value type digital bool is the most basic type of input action. It's usually for a single button press. The input action contains the information regarding whether or not the button is currently pressed. But that's all the information it can handle. Notice there are other types: axis 1D float, axis 2D vector 2D, and axis 3D vector. We'll learn about more of these soon, but let's just keep this at digital bool. And we now have an input action. Great. But what do we do with it? Well, we have to associate it with some kind of input, whether it's a keyboard key or a console controller button, for example. We do that with a new type of asset. We're going to go back to our input folder and make that new type of asset now by right-clicking, going to Input, and selecting Input Mapping Context. Let's choose that and call this IMC for Input Mapping Context Bot. This will be our IMC Bot Input Mapping Context. The mapping context is what we use to link an input action to a given type of input, a certain button or key, etc. Let's open that IMC bot, which again, just like input actions, it's kind of basic, but we need to take a look at mappings. Mappings here is an array. We can add elements to it with the plus icon. And as soon as we do that, we have a dropdown we can expand. And we have a single mapping here, which has its own triangle we can expand, and its own dropdown where we can select an input action. Now, there only exists one input action in our entire project. That's IA Fire. That's the only choice we have. So we can select that, and our dropdown now says IA Fire. And if we expand its triangle, here is where we can choose which key is going to be associated with this input action. Which key do we want to press to fire our weapons, right? Now, we can choose the key or button or any other type of input from the dropdown. If we expand it, we see lots of different categories. If I want the left mouse button, I can find mouse, expand it, and there are different types of mouse input. Most notably is the left mouse button. We can choose that there. and now IA Fire has the left mouse button associated with it. Now we can remove that association by clicking the trash can, which says Remove Mapping. That's going to remove the entire mapping. So if you did that, go ahead and click plus to add that IA Fire back. Now, rather than going and searching for the key or the mouse button, there's a shortcut. We can click on this icon here, select the key value. If we click on it once, it becomes yellow, and we can then press any key on the keyboard, such as the F key, and now F is associated with IA Fire. And we can do the same thing for mouse buttons. I can click on it and click the left mouse button to associate the left mouse button to IA Fire. Now, the cool thing about input mapping contexts is we can associate more than one button to a single input action. We do that by pressing the plus icon next to that mapping. Not the plus icon next to mappings, but the plus icon next to the individual mapping associated with this input action. If I click on plus, I now have an additional input associated with IA Fire, and I can choose what that key can be. I can click on the keyboard and press F, which is a shorthand for finding the F key under keyboard here and searching for it and selecting it. So now left mouse button and the F key are both associated with IA Fire. All right. So the input mapping context is where we tie inputs to the input actions. The last piece of the puzzle is to associate the input mapping context with our pawn. To do that, we go back to the pawn class and open our event graph. Now we can do this in Begin Play, and the way to do it is as follows. And don't worry if you don't commit this to rote memory, because you can always come back to this video and remind yourself how it's done. But the way to do it is as follows. First, we need to access our controller. You see, when we possess a pawn, we do so through a controller. Every pawn that is possessed is actually possessed by a controller. To access the controller, we right-click and search for Get Controller. And we choose Get Controller. This is a function on the pawn class. Actors don't have it because they don't get possessed by controllers. Pawns do. And if we hover over the return type, its type is controller object reference. Now, controller is a base class. It's a parent class, which is very basic. But our pawn has a more specialized child class of controller called player controller. And we need the player controller. We need our controller in the form of the player controller data type. And remember, this is what casting is for. So we can drag off of that controller data type and search for cast to player controller and choose that. And the return type here says player controller object reference. This is a child class of the controller. A player controller is a controller, right? We have that is a relationship going on. So in Begin Play, we're going to access the controller that's possessing this particular pawn, cast it to player controller. And why did we need it in the form of a player controller? Well, that's because we need to access something called the Enhanced Input Local Player Subsystem. Notice under Player Controller, under Local Player Subsystems, we have this function to get Enhanced Input Local Player Subsystem. Now, a subsystem is an object that exists in our game. There's only one of them, and we can access it through this get function that belongs to the player controller. If we click on this Get Enhanced Input Local Player Subsystem, we have this one big fat node that returns an Enhanced Input Local Player Subsystem object reference. And this is how we associate input mapping contexts. We drag off of it and we search for Add Mapping Context. If we select it, we now have a new function call to add mapping context. This is where we can choose the mapping context we want to add. We have to connect this to our cast node. Make sure you don't use cast failed. We need the top execution pin. And we can choose the mapping context from the dropdown. Our project only has IMC bot, so I'm going to choose that. Now there's a priority because we can add multiple mapping contexts at varying priorities, and the mapping context with the highest priority takes precedence. Let's say I had 2 of these with different input actions associated with the left mouse button. If we had both mapping contexts added at the same time, the one with the highest priority is the one that's going to trigger that left mouse button input action. But anyway, now we've added our input mapping context here and associated it with this given controller, and this opens some interesting doors for us. We now have the ability to make use of our IA fire input action, which exists in IMC bot, our input mapping context, which we've used to associate the left mouse button and the F key with it. So I'm going to go ahead and remove these 2 nodes, tick and active begin overlap. We don't need those. And this set of nodes here, where we're adding the input mapping context, this can get its own comment. You could even collapse it into a function if you'd like to do that. But I'm just going to press C to give it a comment and say add bot input mapping context. And I'll go ahead and give it its own color. We'll give it red. Something I like to do is double click the wire here to give it a reroute node. That way, if I need to move the comment around, it's going to anchor to that little reroute node there. So now that we've added the input mapping context, we can choose what happens whenever we trigger the IA fire input action. In other words, the keys and buttons we've associated with IA fire in the IMC bot input mapping context are going to trigger some kind of functionality. We can determine what that is by going to our bot pawn here, right-clicking in the event graph and searching for IA fire. Now we have 2 options here. Something that has a little arrow indicating that it's an event. If we click on that, we have this event we can implement, and we can expand its dropdown, and we see that it has a number of execution pins and data values that it provides. So we can choose what happens in response to triggering IA fire with the F key or the left mouse button. Now, if we right-click and search for IA fire and choose the other option under Enhanced Action Values, this looks like a Blueprint Pure function, right? And that's what it is. Because our IA fire has its value type set to digital bool, there's a Blueprint Pure function that returns the Boolean value that'll be true if those inputs are being pressed currently. If they're not being pressed, the value will be false. So that's a convenient way to check to see if the F key or the left mouse button are currently being held down. But this IA fire event can do that too. You see, we have a number of things that will trigger based on the status of that input. The first one, triggered, will be executed every frame as long as the input is held down. We can prove that with a print string node. We can say triggered. We also have started, which is only executed once when that input is pressed. We can add a print string node for that one. And we can say started. And I'm going to change its color to a more reddish color here. Now, ongoing and canceled have to do with a press and hold threshold, which we have not implemented for this input. That's a little bit more advanced, so we won't touch on those. And completed is going to be triggered as soon as that input is released. We can add another print string with its color set to red, connected to completed, and I'll put completed here for the string. And now we have some responses for when our input action is fired off. Now, I would like to change the duration for these from 2 to, let's say, 60. And that way we can analyze these messages that get printed to the screen. So I'm going to change the duration for all 3 of these print string nodes to 60. And now we can play test, and as soon as I press play and click in the viewport, notice that I have some messages here. Now, the newest messages appear on top, remember? So the started message was first printed to the screen, and then we had triggered printed every frame until I released my mouse button, at which point completed was printed to the screen. So we have the ability to respond to when a button is initially pressed, and the ability to respond to when that button is released, as well as a way to fire off logic continuously every frame while that button is held down. So this is quite versatile. If we only want to perform a single one-off action as soon as the button is pressed, we have started. If we want to trigger something every frame as long as the button is being held down, we have triggered. And if we want something to happen as soon as we've released that input, that's what completed is good for. Now, we don't have to just rely on print string nodes. I'm going to delete those three so we don't have anything hooked up here, and go back and press play and click in the viewport to engage. And I'm going to use a special console command. We can enter console commands by hitting the tilde key on our keyboard. Now this little black text bar pops up, and I can enter the console command show debug, one word, enhanced input, also one word, and if I hit enter, we now see some information at the top left. We see that we're showing debug for BP bot pawn. We can press page up and page down to cycle between targets. So if we had multiple pawns possessed by controllers using enhanced input, the page up and page down keys would cycle to showing information about those objects. Now, we have a number of bits of information here. It even shows my computer name. We have the location and rotation of our pawn. We also see that our pawn is possessed by player controller. That's the class of the player controller possessing the pawn. That's why the cast from controller to player controller was successful. And we also see enhanced input values. It shows that we're using the IMC bot input mapping context and that there's a single action, IA fire, and it has left mouse button and the F key associated with it. Now I'm going to press and hold the left mouse button, and look at this. It shows that it's triggered, and it's also keeping track of how long it's being triggered. I've now held it for 8 seconds and counting, and if I release, now it goes back to 0. So it keeps track of how long we've held an input. That's just built into the enhanced input system. Input actions keep track of how long they're pressed, and that allows us to avoid having to keep track of that using blueprint nodes and such. Now I can press the F key, and we can see that IA fire is being triggered, and we're keeping that running count. And I can release, and it stops. And notice as I'm holding down the inputs, we see true next to left mouse button in this case, or if I hold F, we see true next to F. Because this IA fire has the value type bool, and we get that true as the value in that input action as the button is pressed down. So show debug enhanced input is a nice console command that you can enter while the game is running. Now, something that trips up a lot of students is they'll try to hit tilde when the game is not running, and they'll get this console text box down here. And not all console commands work down here. There are some that only work while you're engaged in the viewport. In other words, a Pi session has to be running, and you have to click and engage in the viewport first before you press tilde, and you get this other in-game console command line. So not all console commands work. In this one down here, sometimes you have to be engaged in the viewport before you press tilde for them to work. But if you press play and start a Pi session and you enter that command down here, show debug enhanced input, it will work because the game is running. So in this case, we can use either one. But if you stop the Pi session and enter show debug enhanced input, nothing happens because the game isn't running. And one other handy tip is if you bring up the command line and press the up key on your keyboard, it's going to automatically populate with the last command that you ran, so that can save you some typing. All right, so I know this was a lot to take in. This is a kind of big lecture, but you can always refer back to this lecture. You can take notes on this lecture, because this is the same process that you'll go through every time you set up a new pawn with input. You always need to create input actions, create an input mapping context to associate those input actions with inputs, and you always have to add an input mapping context to your pawn, and you do that by getting the controller, which returns a controller object reference, casting it to the player controller, which returns a player controller object reference, getting the enhanced input local player subsystem from the player controller, and calling add mapping context, specifying the context and the priority. Now, if you've done some experimenting on your own, you might have found that you can right-click and type get player controller. Now, this is different than get controller. This is a function that returns a player controller in the world with a given player index, as each player in a game has a player index associated with it. And you may find that this will work in a game with one player with a single player index. But if there are multiple players, each one will have a different player index. So it's generally not a good idea to use get player controller, as you don't know if the player index is correct. And you'll notice if we hover over this, we see target is gameplay statics. This is a function library with functions that you can just call from anywhere. Whereas if you hover over get controller, we see the target is pawn, which means this is a function belonging specifically to the pawn class, and it gets the actual controller that's currently possessing the pawn that's calling the function. So this gets us the true controller possessing the pawn. So while you could use a single node to get the player controller and avoid the cast, this is linked to the player index, whereas get controller is linked to the pawn that's calling it, and this is guaranteed to give you the correct controller. So that's just an aside, but that's why we use get controller and cast it to a player controller instead of calling get player controller. All right. So as I mentioned, there's a lot here to set up just to get the left mouse button to trigger some kind of action that we want. But the good news is, now that we've set up our input mapping context, it's going to be very easy to set up additional inputs and add them to that mapping context, associate them with keyboard keys and mouse buttons as well, and allow us to program some movement for our pawn class. So the hard part is out of the way. Now we get to enjoy programming movement for our custom pawn class. So stay tuned, and we'll do that next.